Good morning. Welcome to the next episode of Math 9. We are still in Chapter 1 and our lesson for today will be Lesson 1.2, 0 and negative exponents. Recall that the ones we have had only had exponents which were natural numbers. That means counting numbers 1, 2, 3, 4, 5, 7, 8, 9, 10. We did not consider 0 and the negative exponent. So our objective today will be for you to be able to apply 0 and negative exponents to simplify algebra expressions. Okay, so we have our definition of 0 exponent. Okay, 0 exponents here will be defined as this. Let's say triangle will be any algebra expression that's not equal to 0. This one will be equal to 1. Okay? So any number raised to the 0 is equal to 1 provided that number is not equal to 0. Okay? So our example, if we have here 2x raised to the 0, this is algebra expression 2x, this is our triangle, means this one will be equal to 1, provided this expression inside is not equal to 0. Okay? Next example, suppose we have 2x to the 0. Here we notice the difference between this and this is that only this algebra expression x is raised to the 0, which means 2 will be rewritten as is, okay, and then this will be equal to 1, or this will be equal to 2. Okay, and for this example, let's say 2x plus 3y raised to the 0, and we have an coefficient here, we have 5 times 1 is equal to 5. Again, this will only be true if this expression is not equal to 0. Okay? That's the definition of 0 exponent. And the next definition we learn today will be the definition of negative exponent. Okay? Negative exponent. We'll use this same algebra expression and we get triangle raised to the negative n is equal to 1 over triangle to the n, provided triangle is not equal to 0. Okay, so what this definition tells us is if you have a negative exponent there, we can simplify it by just getting the reciprocal. Okay, so example here, you're going to have here 2x raised to the negative 3. Okay, instead of applying the power of a product right now, we can actually simplify this first and make it positive by using our definition of negative exponent, and we have here what? 1 over 2x raised to the cube, and then and only then can you apply the power of a product. So we have here 2 cube x cube. You have an option to have 2 cube as 2 times 2 times 2 and write your answer as 8x cubed. However, if the exponent of this numerical coefficient here is more than 10, it will not be advisable to have it in this form. Let's say 2 to the 10 will just retain as 2 to the 10. Okay, now another example. Suppose we have here 2x to the negative 3. This is written as read as 2 times x to the negative 3. It's only this expression that is raised to a negative number. So we have here 2 times 1 over x cubed, and then we get here the definition of division. We can write that as 2 over x cubed. Okay, now we can extend this definition of negative exponent to a theorem. Okay, this theorem can be proven using the definition. If we have a numerator over denominator, this is our algebra expression, the numerator, denominator, raised to a negative n. This one is actually simplified by just interchanging the numerator and the denominator and making that exponent positive. Again, we will have here n and d, the algebraic expressions for numerator and the denominator should not be equal to 0. Okay, in this instance, let's say, if we have here, example, let's say 2x over 3y raised to the negative 5. Instead of applying the laws of exponents that we had earlier, we can have to simplify this one first and rewrite it as 1. Exchanging the numerator and the denominator and making the exponent positive will give you this 3 to the 5th y to the 5th over 2 to the 5th. Okay, I should say this one is this one should be x. Okay, again, this one now becomes 3y over 2x raised to the 5th. Or we have here 3 to the 5th, y to the 5th over 2 to the 5th and x to the 5th. That's how we apply this theorem here. So for today, we have learned 3 concepts: the definition of zero exponent, definition of negative exponent, and this theorem here. Let's have an example of applying zero, negative exponents, and the other laws of exponents that we have had in the previous days. For this number, you have 3 groups of factors. It would be well for us to simplify within, to remove the negative exponent here, negative exponent there, or distribute this applying the power product, power of a power. I think it would be more convenient if you're going to apply the power of a product and power of a power at this moment. So for this first factor, we have 5 to the negative 2, and then here x to the negative 3 raised to the negative 2, and this is y squared raised to the negative 2. Similarly, this factor here, negative 2, is raised to the cube, x squared is raised to the 3, and then y negative 5 is raised to 3. For this group of factors, that's raised to the 0, so that's equal to 1. Simplifying this, we have 5 to the negative 2 can be brought down. It will give 1 over 5 squared. And this is x to the negative 3 times negative 2 will be x to the positive 6. This is y squared. That will be y to the negative 4. This will be minus 2 raised to the cube is actually minus 8. Okay, then this one is x to the 6. And this is y to the negative 15. Further simplifying this by applying the product law, we will have on the denominator 5 squared, and then a negative 8 on the numerator, x to the 6 plus 6 is 12, and y to the negative 4 and negative 15 will give me negative 19. And since this is a negative, we can bring it down. If there's a negative in the coefficient, put the negative before the fraction to arrive at 8 over 25 and x to the 12, y to the 19. So what did we actually do here? For our convenience, we did not simplify this and said 1 over x cubed. Instead, we applied the power of a power with these negative exponents, positive exponents, for us to arrive at this solution. For exercise number 2, and you're dealing with these numerical bases, the best thing to do is to make this into prime base form. Okay? Prime base form, prime base form, prime base form, and prime base form. Okay. Now, I will write the solution up. What do you think will be the prime base for 64? Okay. What do you think? It can be 4 raised to the cube, but 4 is not prime. So we can have 64 as what? 2 raised to the 2 times 2 is 4 times 2 is 8 times 2, 16 times 2, 32 times 2 is 64. So that one is 2 to the 6. Okay, 64 is 2 to the 6, and this is an exponent of 2 minus x. Okay, times 27 is easy to see that the base form for 27 is what? 3 raised to the cube, and the exponent is what? X plus 5. Okay, and then 16, it's easy to see that's a base 2 raised to the 4, and then we have 2x minus 3. And 81. 81 would be what? 3 to the 4 raised to the negative 5 minus 2x. And from here, you can apply the power of power to get us what? 6 times 2 is 12 minus 6x times 3 to the 3x plus 15, and then this is 2 to the 8x minus 12 times 3 to the negative 20 negative 8x. Okay, remember that by the first of exponent, 2 to the 12 minus 6x is actually 2 to the 12 times 2 to the negative 6x. Okay, similarly with this, 3 to the 3x times 3 to the 15, 2 to the 8x times 2 to the negative 12, etc. Okay, now, we can now, from law number 1, we can combine this same base and we just add the exponents. Okay, so what do we have there? Here, we get base 2, this is 12 plus negative 12 is 0. Okay, so we only have negative 6x plus 8x will be 2x. So that's the only exponent that's left for the base 2. What about the base 3? We have here 3x and minus 8x will give me what? Negative 5x. Okay, and then 15 and minus 20 will give me what? Negative 5. Since both of these are negative, we can further rewrite this as negative of 5x plus 5. Or you can actually write your answer as what? 2 to the 2x all over what? 3 to the 5x plus 5. So we read that ourselves with the negative exponent. Okay? So again, when you come up with these ones here, numerical coefficients, is always nice to transform them to prime base form. Okay? Prime base form. Okay, let's get to example number 3. Okay, for example number 3, what do you notice? We have a quotient and we have the exponents, either negative or positive, but some of the factors can be simplified as they are. Okay, so for example, I may not proceed distributing this negative exponent to the numerator and the denominator. I may opt to simplify within first, which I can see here. This 15 and 3 can be a 5. So I will have a 5 in my numerator. Okay, now, a negative 5 and a 2. We can bring this negative down here and it becomes a to the 5th. If you bring this down by definition of negative exponent, we have an a to the 5th and a squared will give you a to the 7 because of law number 1 also. Okay, what about the b? B cubed and b6. Quotient law will tell you that we just have to subtract this. If you subtract 3 and 6, you have 3 minus 6, you will get a negative answer up. So the wiser thing to do is bring 3 subtracted here down because it will be, you will have a positive answer. So bring this down, it becomes b to the negative 3 and 6 minus 3 will be 3. So you will have a b3 on the denominator and we have here a negative 2. Okay? Similarly, we can simplify within here. So 6 and 30 can be cancelled and we have here 5 on the denominator. 5. And a2 and a5 quotient law, subtract which is ever bigger, okay, and you will get a cube on the denominator. And then this one here, this is negative, you have to bring it up, instead of this bringing it down, bring this up, so you have b cube, and we will have a b to the 7 on the numerator, okay, and then that's a negative. Okay, so what do we have here? Instead of distributing this negative to this one here, we now have to use the theorem. So what does the theorem tell us? Make this one positive and invert this numerator. Okay, and then similarly, we will apply it here. We have 5a cubed over b to the 7. Then and only then can we have this exponent. Okay, so power over power will give me a to the 14, b to the 6 over 5 squared. And then here we get 5a cubed over b to the 7. Again, you can do your cancellation. Numerator, we have a14, a cubed, you get a17. Okay, nothing is cancelled. Okay, 5 and 5 squared here cancels, so we have a 5 on the denominator. And then b6 and b7, b on the denominator. So that gives you the answer. Okay, that's for number 3. Okay, we are running out of time. I just want you to look at this number here, xy raised to the negative 1. Instead of distributing the negative, you can say 1 over xy. And it will be a no-no to distribute the negative to these exponents here. Instead, you have to, because we don't have a power of a sum. We have a power of a product. Power of a product is xy raised to the n equals x to the n, y to the n. But we don't have this. This is not always equal to this. Okay? So we cannot distribute the exponents. Okay? So in this manner, you're going to have the definition of exponent, negative exponent, and you write this as 1 over x squared, and this one is 1 over y squared. And then you simplify within. Okay? Similarly, for this one, for the last number, x to the negative 1 plus y to the negative 1, over this, you cannot actually distribute this. You cannot also bring this one up, this one down to have a positive exponent, or this one up, and these ones, because these are terms, so you cannot. The best way to do this is a numerator, denominator. I can have that become positive by interchanging the numerator and the denominator here already. So we get what? X minus 1, y to the negative 1, and the denominator is what? X minus 1 plus y to the negative 1. And this one is raised to the positive exponent already. Okay? Now, you can now simplify here. Again, I said you cannot bring this down and make it positive because of this sum and difference here. Okay, so we can have to apply this negative exponent definition individually. Okay, individually, 1 over x plus 1 over y. And you can simplify this by multiplying this whole complex fraction with the LCM that will cancel this ones here. That will cancel that one. Okay? So what will cancel x? It will be x. What will cancel y? It will be y. Same thing is x, same thing is y. But that has to be xy over xy so that this is equal to 1 and you are not changing the value of this expression. Because you're just multiplying this expression by 1. Okay? So this 1 times this will give you a y. This 1 times this will give you an x. On the denominator, this 1 times this will give you a y. This 1 times this will give you an x. Now, this is our answer. May we cancel y and y or x and x? No, because this one is part of its other. These ones are part of its other also. This is, the operation here is negative and this positive. So you cannot cancel these ones. So we are left with this answer. Okay, for your homework, you can have this one on your workbook, even numbers on pages 4 and 5. I hope that was Clear enough? Okay, you can private message me if you have questions on the exercises. Thank you and good day.